I am Sichuan Dong from Shanghai Foreign Language School, affiliated to Shanghai International Studies University. My project is a study addressing school mental health concerns based on deep face neural network, combining programming skills with psychological care. At SFLS, it is traditionally the psychology representative of the class who fills out forms to keep track of everyone's mental state, which consumes pretty much time but cannot ensure validity. Could there be an automatic system that instantaneously records students' emotions while also guaranteeing accuracy? To arrive at such goals, firstly, we need algorithms to support both face and facial expression recognition in a campus setting, and in addition, we should provide humanized service, including continued tracking and information protection. First of all, I investigated some previous works on facial expression recognition, such as the elastic graph matching approach, or EGM, and the k-nearest neighbor approach, or KNN, and found that despite the high accuracy, they did not put an emphasis on the relationship between the facial expression data and people's mental health. Therefore, my project will focus on predicting students' mental states with their facial expression data. Here is a more detailed framework. In face detection, I adopted the convolutional neural network YOLO v3, or You Only Look Once version 3, for face classification according to an augmented dataset of me and my mother with name tags. After 2,946 epochs of training, its training and testing losses lowered to an acceptable level. In this real-time photo, it successfully detected me and my mother with high accuracy. Next, in facial expression recognition, I, along with my advisor, compared two convolutional neural networks, Mini Exception and Modified VGG19, or Visual Geometry Group 19. Their structures and parameters were both modified to adapt to 4-category sorting: angry, sad, disgusted, and positive, which center on negative emotions. The networks learned the dataset FER 2013, which was also modified to eliminate noises and reduce the number of categories to 4. After a series of training and testing, we chose modified VGG19 instead of Mini Exception because the loss value of the former was lower and more stable. We may also tell from the real-time photos that the result of modified VGG19 makes more sense than that of Mini Exception. The next part connects objective data of facial expressions to an accumulated emotional problem. The Quantified Integration model keeps track of students' possibilities of each negative emotion continuously, until the accumulated possibility reaches half of the standard within an observation period, when an alarm will be automatically sent to the psychology teacher. To determine the length of the observation period, I contacted my psychology teacher and a specialist from a regional mental health center, and received their standard of recognizing depression and other mental health problems. Therefore, one with 7 days is long enough not to cause alarming by chance, and short enough for the purpose of prevention. The data at different locations on campus are also weighted differently due to the variations in emotions' influence on facial expressions under different circumstances. Then, to protect students' privacy rights and safety, we need a written consent before implementing this technology on campus, and encrypt information sent to the psychology teacher into ciphertext to ensure that the information, if stolen, will only appear as incomprehensible texts. In this way, RSA protects information security more safely and ensures students' right of portrait. In conclusion, this system uses convolutional neural networks for face detection and facial expression recognition. It can monitor students' long-term mental health and protect the safety of information and privacy. In the future, I will expand datasets and test the system in the actual campus setting. Thank you.